What is faster, sound or light? What type of question is it?
Ah,
Sound.
Think so?
That's what yours is did.
The
Hold on.
sound was moving?
Let's see.
Hold on.
ah.
I think sound, bro. That shit, that was fast as fuck, though. I ain't gonna lie.
That light was kind of moving though.
Now,
Nigga.
that time that light was moving, let's do 1-1 then. 1-1.
Let me give it a head start.
Huh.
Sound, bro.
Sound?
The sound, bro.
Huh.
Ta.
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 Huh.
Dude, that was a tie, too.
Ta.
That was a tie, bro.
As you can see in this video, these two philosophers are studying what is faster, light or sound. And in this video, I'm going to tell you exactly which is faster and why it's faster. To understand which one of these is faster though, we need to understand what sound really is, how it interacts in different environments, and the difference between sound and light, because they are very different things. Sound is something you hear, right? And when you hear it, like it feels like you hear it like really fast when you perceive it. But the truth is, like, we can't actually perceive how fast sound really is. Not just sound in general, but there's plenty of sounds that we can't actually hear. Like the cells on our body moving, we can't hear that. And there's a lot of low pitched and high pitched sounds that we can't actually hear. You can't really say that speed of sound is how fast you hear it, because sound goes beyond human comprehension. There are sounds, a common misconception is that there are no sounds in space, and that's not true. While it is true that it's harder for sounds to travel, because in space atoms are very far apart, and by the time one atom that vibrated goes to another atom, the energy that the sound brought with it, it would be gone by then. But sound can actually travel through dense dense things in space, such as like plasma inside of stars or dust clouds. It can travel in those kinds of things. So technically there is sound in space. We just can't hear it. But scientists can detect sound in space. There's a galaxy known as the Perseus galaxy, if I'm saying that right. And it was discovered to have like pressure waves rippling through the gas inside of it. And those pressure waves can be viewed as sound, because like sound, it creates vibrations. There's a lot of vibrations that happen in space, but because of how far apart the atoms are, it's harder for sound to happen itself. It would have to be some sort of cosmic event happening. If we're gonna compare sound to something like a light that's also massless, we're gonna have to view it like outside of human perception. Sound exists outside of you hearing it, because in physics terms, it's just vibrations. It's just particles and atoms rubbing on each other basically. So it's just, if a physics rule is that if particles are able to interact with each other, then that counts as sound. On Earth, we know that sound can travel as fast as 767 miles per hour. But in space, this is a different story, because sound waves travel very differently in there. In cosmic environments like hot plasma gases, sound can travel up to 149.13 miles. And now we get to light. So you probably already know this, but light is usually considered the fastest thing in the universe. And the thing about those two philosophers, Bilu and Zayas, they're both brilliant. You guys both are brilliant people, but your little experiment won't work, because you're comparing two different things, because how fast the light traveled depended on your finger touching a flashlight on your phone. And the same thing with sound, it depended on how fast the sound came out of your throat. But when we're talking about things in space, it's a different story, because things in space can travel really fast actually. And we can see like light hit a surface, but we cannot, there's no way for our brain to comprehend how fast light moves. Light moves 299,792 kilometers per second, Oh, wait, I'm American. Light moves exactly 186,282 miles per second. Second, not hour. Per second. That's how fast light moves in 1 second. So let's compare 149.13 miles per hour and 186,282 miles per second. Let's see what happens if light and sound go in a race. Ah! No, I'm just kidding.